Hi, this is Bobby,
Hi, this is Susie.
and this is our ECE 202A final presentation, and our project topic is sneeze detection. And first of all, I will give you an overview of our project. And our project uses Arduino 33 Nano, a BLE sense board to detect a human sneezes. And upon detection, the Arduino board will send a message to the computer, and the computer will give the user a bless you message when a sneeze is detected. And our system is aimed to be accurate, reliable, and robust. And this figure shows that the whole pipeline of our project and our system. So first of all, I would like to start off by saying some changes that we have made from our midterm presentations. Uh, One of them would be we implemented a three-layer neural network classifiers for our sneeze detection. Originally, before the midterm, in the midterm presentation, we only implemented random forest algorithm as our primary classifier. And secondly, we collected data with like different threshold and also sampling frequency, and we compared these results for from uh, with the results that we got like in before the midterm. And also, we completed the BLE communication between Arduino board and the computer. And in our midterm presentations, uh, there's issue with the buffer of the computer when we trying to establish the Bluetooth communication. Right now, we is able to solve this problem, and the more detail will be further discussed during this presentation. And right now, Sushi will go on with the technical approach of our project.
So for our hardware, we choose Arduino Nano 33 BLE Sense board, as Bobby mentioned. It comes with a digital microphone, which is very sensitive and reliable to use. It also has Cortex M4F microcontroller, and also it contains a BLE communication module, which is necessary for our project um, because we don't need to buy extra Bluetooth chip, and so we don't need extra wires, which means the size of our current device is relatively small for now. And besides that, we need a laptop that has Bluetooth enabled. So for our data collection, we collected around 100 sneeze samples from the website Freesound, and we have also collected another 100 samples for background noises such as tapping, snapping fingers, clapping hands, those noises that has similar pattern as sneezes. And we also experimented with different sampling frequencies and thresholds. For our microphone sampling frequency, it's 16K hertz, and our data sampling frequency is around 200 hertz. Um, our algorithm is that the microphone would only start recording if the environment sound the, is bigger than 400 hertz. By setting threshold as this, we can get rid of unwanted low frequency noises. So to process our data, first we did microphone calibration. For the first 3 seconds since our system started, to get rid of unwanted background noises and offset. And then we perform fast Fourier transform to convert our data from time domain to frequency domain. We can see from the pictures below, the left one is FFT waveform for sneezes, and the right one is waveform for coughing. We can clearly see that the peak for sneeze is around 5,000 to 6,000 hertz, and meanwhile for cough, the most significant peak is like less than 2,000. So comparing them together, we believe that it is better for um, us to do feature extraction from frequency domain, because if the data is in time domain, then the predominant factor would be amplitude peak, which will not be much useful in sneeze detection. And finally, we applied FIR filter to our data and make our waveform smooth, also better for the classification. For machine learning part, we've tried two Python libraries. The first one is sklearn, and we tried SVM, decision tree, logistic regression, and random forest classifiers. And for each of the classifiers, we adjusted different parameters and tried to get the highest training accuracy possible. And we also tried Python TensorFlow library and used that to constructed a 3-layer convoluted neural network classifier. During that, we also made adjustments about critical parameters such as dropout rate, the number of layers, and loss functions. Lastly, before our trend classifier could be used by Arduino, we need to deploy them into plain C code, because Arduino would only read C instead of Python. And for communication, we use BLE, and on Arduino side, we use Arduino BLE libraries. On the computer side, we use Bleak library. After the sneeze is detected, a byte containing 1 will be sent from Arduino to the computer, and when the computer receives that signal, it will print out "bless you" on the screen, also with a background sound. So Bobby's gonna analyze experimental results of our project.
Yes. So, as Susie mentioned, that we have tried 4 different classifier from sklearn, and the highest result we got is from random forest classifiers with an accuracy for around 97.4%, and we would like to compare it with like commonly used machine learning algorithm, the convoluted neural network. And in the training accuracy, the convoluted neural network is getting around 89.7%. And uh, in the pictures below, these are the confusion matrix on the random forest classifier and the convoluted neural network, since like those two are the highest classifier in all these classifier that we tried. And in the picture you can see that like both of the classifier is doing pretty well when detecting the background noises, but uh, the convoluted uh, neural network is doing worse when detecting the sneeze, and random forest has a better result, theoretical results when detecting the sneezes. But in reality, when we implemented those classifier into the Arduino board, we find out that the accuracy from using the neural network is about like 95%. You can accurately classify as sneezes. But on the other hand, for random forest classifier is only getting accuracy around 80%. So at the end, we decided to implement neural network as the primary classifier for our system. So in conclusion, we achieved reliable sneeze detection by embedding machine learning algorithm into the Arduino board. So we implemented like the TensorFlow uh, convoluted neural network into our system. And we also established wireless communication between Arduino board and laptop via Bluetooth, the BLE on board. And we also optimized our classification algorithm to deal with like the confusing cases like such as the snapping finger and coughing, which have like a similar pattern to sneezing. So this increased the robustness of our classification. So in the future, uh, we could improve our system by implementing like motion sensors into our system, since that currently we our system don't have like a reference knowing that like where the position it is uh, on our body. So maybe the signal that we will get from putting the device on the wrist will be different than the signal that we collected if it is like wearing on the neck. So we could implement like motion sensors to estimate the position of the device on the human body and also cooperating like a weight variable that like will adjust like where's the devices on the person to improve the classification. And secondly, we can also improve our system by having a better filtering system, since that right now when we are capturing the audio signal, there's even though we implemented like the FIR filter, there's will still be like random peaks of noises that will trigger the system to capture the audio. But in reality, there's like no such signal exists. So we will, by implementing a better filtering system, we can get rid of those random spikes of the signal. And third, we can also optimize the size of our systems, since like currently we are using the Arduino Nano 33 sense board, and it has like a few more different sensors that on board, but like we don't really need all of those sensors. All we need for our system is the microphone and also the microcontroller. And if we implemented the motion sensors, maybe the also the IMU 9S IMU we want to keep, but like the rest of the sensors is not necessary for our project. So with more time available, we could create our own PCB that includes those modules and also the microcontroller to like minimize the size of our design. Uh, So that would conclude everything for our project. Thank you.
Thank you.